Hi students, in this video we will be going over solving systems of equations. This time we're going to be talking about solving these systems algebraically, whereas before we're solving them by using graphs. So our essential question for today is, how are systems of equations solved algebraically? Once again, how are systems of equations solved algebraically? Now, these are our 5 steps, and I encourage you to write them down. They won't make a lot of sense yet, but once we start going through it, then I think you're going to start seeing how these do make sense. So the first step is to write the system so that the like terms are aligned and in standard form. Now, we've pretty much been working in y equals mx plus b, which is slope-intercept form, and now we're going to be working in a different form, which is called standard form. Now, standard form looks like this. It's ax plus by equals c. And this should look pretty familiar to you because I think we did a couple problems with this form last time. So you want to get your system in that form, and then you're going to have to eliminate a variable such as x or y. You might have to multiply these equations so that you can eliminate them. Eventually, you're going to plug back in that number that you found into either equation to solve for the other variable, and always check your solution. So like I said, this probably won't make a lot of sense until we start going through it. So let's go through one solution problems. So let's talk about the first couple steps. So write them so that the terms are aligned and in standard form. Now look at this. These are perfectly aligned. The x's are over the x's, the y's are over the y's, and your constants are over your constants. So they're in perfect form, which makes this very easy. Now our goal is to eliminate one of the variables, and the variable will need to become a 0. Now the easiest one right now, if you look at this to eliminate, imagine if you were adding, kind of like you would say you had like a number like 560 plus 270. Imagine you're doing the same thing with these equations. But the easiest one is going to be to eliminate the y, because you've got a -4 and a +4, and when you add those together, that gives you 0. Okay, so we've determined which ones need to be eliminated. We don't need to multiply the equations because this one will perfectly eliminate. So that step is done. Now what we are going to do is we are going to start eliminating. And imagine that this is just like adding. Okay, so 3 plus 2 is going to make 5x. These are going to cancel out, which is going to give you 0y. And -8 plus 8 is 0. Now this all simplifies just to be 5x equals 0. And when you divide both sides by 5, you get x equals 0. So we know one of our solutions is x equals 0. So I'm just going to put that up here for now. And now we have to find y. And this is the easy part, because all you have to do is pick one equation, and it doesn't matter which one, and plug in the 0 into the x and solve. So in this case, I'm going to plug the 0 into the first equation, and it is x. So 3 times 0 is 0, which leaves me with just -4y equals a -8. I divide both sides by -4, and y equals a +2. So our solution then to both of these equations is 0, 2. Now if you want to check this, you can always use graph paper, or if you want to do a quick check, you can use Desmos to graph it. But if you were to graph this, you would see that those two lines would cross perfectly at 0 and 2. Now that is an example of one solution, because you have one specific solution. We're going to go over again those many and no solutions in just a little bit. But it is helpful to check your solution. And again, it doesn't matter which equation you choose. Just pick one and plug those two numbers into their variables. So the 0 goes into the x, and the 2 goes into the y. 2 times 0 is 0, and 0 plus 8 is 8. And these two sides match each other, so the left and the right. 8 does equal 8, which means that this is the correct solution. And so it checks out. So as you can see, it's actually pretty easy, and in some ways I think it's a little bit quicker than graphing. Okay, let's go through another example. Now this time it's a little bit different. We've got one where you have to do some multiplying because this is an 8 and a -1. This is a 7 and a -8. They don't really line up. So again, we want one of those to become 0. So let's look at the x's and y's. Which variables could you multiply to get to the opposites? Now that doesn't mean you're multiplying both equations, you might just be multiplying 1 so that the variables will cancel out. And it looks like x is going to be our best option because 7 and 8, those aren't really as easy numbers as 1 and 8. Because if I do 1 and 8, I only have to change the bottom one. Now, if I did the y's, I'd have to multiply this by 8 and this by 7. But if I choose the x's, then I only have to multiply the bottom by 8 to get the opposite. So let's see what that actually looks like. So here are my two equations. And again, I want these x's to become the opposite of each other. I want 1 to be an 8. I want 1 to be a negative 8. So if I multiply everything in this equation by 8, I end up getting a whole new system. Now the first number, the first equation stays the exact same. See how that didn't change at all? However, 8 times a negative x gave us a negative 8x. 8 times a negative 8y gave us a negative 64y. And an 8 times negative 5 gave us negative 40. Now, the reason we did this is because now these two numbers, 8 and negative 8, they'll cancel out and our x's are gone. And that was our whole goal. So let's look at that. So with our new system, that perfectly cancels out, and I'm left with a negative 57y, because 7 plus negative 64 is a negative 57. And negative 17 plus negative 40 is also negative 57. So I'll divide both sides by negative 57, and y equals a positive 1. So this time we found the y first, whereas in the previous problem we did x first. So we know y is 1. Now, all I have to do now is I can choose either equation to plug that 1 in and then solve. So I'm just going to choose the first one because those numbers look a lot nicer. So 1 is going to go into that y, and 7 times 1 is 7. So I get 8x plus 7 equals negative 17. And I subtract 7 from both sides, which will give me an 8x equals negative 24. Divide by 8 on both sides, and x equals a negative 3. So my point is negative 3 and 1. And you can also go through and check your answer to see if that is correct. So again, it doesn't matter which equation you choose. Again, this one, I think the first one looks a lot nicer. So when I plug in those numbers, negative, is that right? Yes, negative 3 and 1. The negative 3, which that should have been a negative right here, up in the right, goes into the x, and the 1 goes into the y. So 8 times negative 3 is negative 24. 7 times 1 is 7. And when I add those together, both sides perfectly equal each other. So we know the solution is negative 3, comma 1. So negative 3 as the x, 1 as the y. All right, let's look at another one, this time where we might have to multiply twice. So I know there's quite a few examples in here, but I want to give you a lot of things to be able to review. So again, our goal is to eliminate the variables so that one of them becomes 0. Now we look at the x's and y's, and this time it's not as easy because there's nothing I can multiply 3 by to get to 8, and there's nothing I can multiply 5 by to get to 6. So most likely I'm going to have to multiply both equations by some number. So it really doesn't matter which one you choose, just choose the one you want to eliminate. So I've got my two equations, and what I'm going to do is I think I'm going to eliminate the y's. And what I'll have to do is I'll have to multiply this by 5, and that'll become 30. And if I multiply this by 6, then that will also become 30, but it'll be a negative 30, and then it'll have the ability to cancel out. Okay, so I'm going to multiply this entire equation by 5, so this becomes 30, and this entire equation by 6, so it becomes negative 30. And I'm not going to walk you through all the multiplication of this because I think you guys know how to multiply at this stage, but you would just take a moment and multiply every term by 5 and every term by 6 to get this new equation. So we get negative 40x plus 30y equals negative 120, and 18x minus 30y equals negative 78. As you can see, these are the opposite of each other, and they are going to cancel out perfectly. So just keep track of your new equations as you make them. And when we set up our addition, that cancels out. And negative 40 plus 18 is going to give us negative 22x. On these ones, negative 120, negative 78, the signs are the same, so you add. And when you divide both sides by negative 22, it works out perfectly, and it is x equals 9. So we've got our x value. Now we need to plug in 9 to either of those equations and solve. And I think the bottom one just looks a little bit nicer. So I'm going to plug 9 into x, and 3 times 9 is 27. I need to subtract 27 from both sides, which will give me negative 40, because again, that will be the signs are the same. Divide by negative 5 on both sides, and that should not be x equals 8, but y equals 8. And I know I went through that a little bit fast, but that's just because we've spent a lot of time solving equations, so this should be a very familiar process to you. So we find out 9 and 8 are our answers. Now again, you can go through and check your answer. I'm not going to walk you through all this, but if you do go through that process, you can check that your answer is correct, and if both sides equal each other, then your answer is correct. All right, let's look at a no solution, and then we'll look at a many solution, and then we will be done. So again, same exact steps as one solution, but in this problem, you can see that I need to write them in standard form. So I need like an ax plus by equals c type of problem. Okay, so once I move this, all I need to move in this first equation is I just need to move the positive 12y over. So it becomes a negative 12y, and then it's perfect. That 15 can stay there. In this one, I just need to move the negative 4x over. So when it comes over, it'll be a positive 4x. Now again, we don't have two equations that are where I can cancel out a variable. But what's really nice is look at on this one, actually on both of them, if I multiply this by 2 in the denominator, this will become the opposite of negative 8. It'll become an 8. And this will become the opposite of negative 12, so it'll become a positive 12. So let's go through and eliminate those variables. So I'm going to times both sides by 2. And our new system will look like this, because once I multiply this denominator by 2, I get 8x plus 12y equals negative 16. And this is going to cancel out really nicely. But you're going to notice something interesting happen here. The negative 8x and the positive 8x, they cancel out. But so does the negative 12y and the positive 12y. And everything that's left on that left side is just a 0. But on this right side, it's saying 15 equals a negative, or 15 plus negative 16 is a negative 1. Now, those two numbers do not equal each other. This is different than when we were doing one solution. When it was one solution, if we got 6 equals 6, then we knew it was perfect and our solution worked. But in this case, 0 does not equal negative 1, so we know that we have no solution. All right, let's look at many solutions, and then we will move on, and you can do your practice. So again, we need to get this in slope-intercept form. So I'm going to move this 10y over here to become a negative 10y. And then in this case, actually, you can just kind of flip these around, because the 8x and the 2y are already by itself, and so is the 6, which is the goal. But if you do change sides, just change the signs. So this became a negative 8, this became a negative 2, the 6 came over here, and it became a negative 6. So that whole process. Now, look at the numbers and see which ones will multiply easily. And similar to last problem, if I multiply the 8 by a 5, I'll get to 40. And the 2 by 5, I'll get to 10. However, these will both be negatives. And this is already a negative, and that's not going to cancel out. So when we do go through our process of eliminating and trying to get something to become 0 this time, we're going to need to multiply this bottom equation by a negative number. That way, this becomes a positive 40 or a positive 10 and can be eliminated. So our new system will look like this. The first equation stayed the same, but this became a 40x, and then a 10y, and then a 30. Now, when you go through and you eliminate, you're going to actually see every single number will eliminate. Okay, everything cancels out here, and negative 30 plus 30 will also be 0. Now, in this case, it's a little bit different. Remember when we were checking before, and if 6 equals 6, that was one solution. That's because you were checking. In this case, when you actually solved the equation, you didn't get x equals something or y equals something. You eliminated everything. And then once you eliminated everything, both sides equaled each other. And that means that you have many solutions. Now, one thing I do suggest is use Desmos to check your answers. It is a great resource. You still need to show the algebra, but it is a great way to see if you're getting it correct without having to resubmit. So you do have 4 practice problems on your foldable to try. Give those a shot and input them into Edpuzzle. If you have any questions, let me know.